After the main 200 amp 3-phase meter and a 100 amp 3-phase disconnect that feeds 5 meters, the panels fed by those individual meters are considered subpanels. A subpanel is a secondary electrical panel that receives its power from the main electrical panel or, in this case, after the individual meters. The key characteristic of a subpanel is that it does not contain the main service disconnect for the building or dwelling unit. The main service disconnect is located at the main panel or ahead of the meters in this configuration. The subpanels rely on the overcurrent protection at the main panel or at the individual meters to protect the subpanel feeders. Grounding and bonding in subpanels must be done correctly to ensure electrical safety. The neutral and ground buses in a subpanel must be kept separate. This is a critical safety requirement outlined in the National Electrical Code, specifically Article 250. This separation prevents neutral current from flowing on the grounding conductors, which can create a shock hazard. The grounding conductor from the subpanel should be run back to the main panel and connected to the main panel's grounding bus bar. This establishes a proper ground fault current path. All metallic components of the subpanel, such as the enclosure, must be bonded to the grounding bus bar. This ensures that any fault current will safely return to the source, tripping the overcurrent protective device. Each subpanel requires its own grounding electrode conductor connected to a grounding electrode system. This ensures that the subpanel is properly grounded to earth, providing a low impedance path for fault currents. The size of the grounding electrode conductor is determined by NEC Table 250.66. Based on the size of the unrounded conductors feeding the subpanel. The subpanel feeder conductors must be properly sized to handle the expected load. The size of the conductors is determined by NEC Table 310.16 based on their ampacity. Overcurrent protection must be provided at the point where the feeder conductors originate, typically at the main panel or at the individual meter. This overcurrent protection protects the conductors from overload and short-circuit conditions. When working with electrical panels, it is essential to de-energize the circuit before making any connections. This can be done by turning off the breaker that supplies power to the panel. Use a multimeter to verify that the circuit is de-energized before proceeding with any work. When connecting conductors to terminals, ensure that the connections are tight and secure. Loose connections can cause arcing and overheating, which can lead to electrical fires. Use a torque wrench to tighten the connections to the manufacturer's specifications. Label all circuits clearly and accurately. This makes it easier to identify circuits in the future and prevents confusion. Use a permanent marker or label maker to create clear and durable labels. When running conductors through conduit, ensure that the conduit is properly sized and supported. The conduit should be large enough to accommodate all of the conductors without overcrowding. Support the conduit with appropriate hangers or straps, spaced according to the NEC requirement. When making splices, use approved connectors and follow the manufacturer's instructions. Ensure that the splices are properly insulated to prevent shorts and ground faults. Inspect all wiring and connections for damage or defects. Replace any damaged or defective components. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Electricity can be dangerous, and it is important to take precautions to avoid injury or property damage. In summary, subpanels are secondary electrical panels that receive their power from a main panel or, in this case, after individual meters. They do not contain the main service disconnect. Proper grounding and bonding are essential for safety. Neutral and ground buses must be kept separate. Feeder conductors must be properly sized and protected. Always de-energize circuits before working on them. Use approved materials and methods. If you are not comfortable working with electricity, hire a qualified electrician. Understanding these principles is crucial for safe and effective electrical installations. Firstly, ensure the subpanel is properly grounded by connecting the grounding conductor to the main panel's grounding bus bar. Secondly, bond all metallic components of the subpanel to the grounding bus bar. Thirdly, provide overcurrent protection at the origin of the feeder conductors. Fourthly, de-energize the circuit before making any connections. Fifthly, use a multimeter to verify the circuit conduct is de-energized. 6thly, tighten connections securely using a torque wrench. 7thly, label all circuits clearly and accurately. 8thly, properly size and support conduit. 9thly, use approved connectors for splices. 10thly, inspect wiring and connections for damage. The main panel houses the service disconnect, which is the primary means of disconnecting all power to the building. The subpanel, on the other hand, does not have this main disconnect and relies on the main panel for overcurrent protection. The purpose of a subpanel is to provide additional circuit capacity for a specific area or set of loads. This allows for more convenient and organized distribution of power throughout the building. Common applications for subpanels include garages, workshops, additions, and individual apartments within a multi-unit dwelling. In a multi-unit dwelling with individual meters for each apartment, the panels within each apartment are typically subpanels. The main service equipment is located elsewhere, usually at a central location where the utility company's service entrance conductors terminate. The feeders from the main service equipment to each apartment's meter are protected by overcurrent devices, and the apartment's panel is fed from the meter. The main panel's grounding system is crucial for the overall safety of the electrical system. The grounding electrode conductor connects the main panel to a grounding electrode system, such as a ground rod or a water pipe. This grounding electrode system provides a low impedance path for fault currents to return to the source, which helps to trip the overcurrent protective devices and prevent electrical shock hazards. The subpanel's grounding system is connected back to the main panel's grounding system. This ensures that all metallic parts of the electrical system are bonded together and that a common ground potential is maintained. It is important to note that the neutral conductor in a subpanel must be isolated from the subpanel enclosure. This is achieved by using an insulated neutral bus bar and ensuring that the neutral conductor is not bonded to the enclosure. The grounding conductor, on the other hand, is bonded to the enclosure. This separation of neutral and ground is essential for preventing circulating currents and reducing the risk of electrical shock. When installing a subpanel, it is important to follow all applicable electrical codes and regulations. The National Electrical Code provides detailed requirements for the installation of subpanels, including the size of conductors, the type of overcurrent protection, and the grounding and bonding requirements. It is also important to consult with a qualified electrician to ensure that the subpanel is installed correctly and safely. If you are unsure about any aspect of the subpanel installation, it is always best to seek professional assistance. Improperly installed subpanels can create safety hazards and can potentially damage electrical equipment. Remember, electrical work should only be performed by qualified individuals who have the necessary knowledge and experience.